In December
The scans are active.
2025,
Patterns are emerging in the
researchers at
parietal and frontal
Vanderbilt
regions.
University
This
made a
aligns with
discovery
deep
that
meditative
challenges
states.
everything we thought we
The
knew
scans are
about the human
active.
brain.
Patterns are emerging in the parietal and
Using
frontal
advanced
regions.
MRI
This aligns with deep
technology,
meditative
they
states.
observed something
The
extraordinary
scans are active.
happening inside
Patterns are
the
emerging
brains
in the
of
parietal and
meditating
frontal
Tibetan
regions.
monks.
This aligns with deep
The
meditative
fluid
states.
circulating through their brains
The scans
began
are
moving in
active. Patterns are emerging in the
identical to those
parietal and
seen
frontal
during deep
regions.
sleep,
This aligns with
except
deep
these
meditative
monks were wide
states.
awake.
The scans are
The
active.
cerebrospinal
Patterns are
fluid
emerging in the
that normally
parietal and
removes
frontal
toxic
regions.
waste
This
from our
aligns with deep
brains was
meditative
being
states.
controlled consciously
The scans
through
are
nothing
active.
more than
Patterns are
focused
emerging in the
attention.
parietal and frontal regions.
This
This
wasn't
aligns with deep
mysticism or
meditative
spiritual
states.
belief.
The scans
This
are
was
active.
measurable,
Patterns are emerging in the
repeatable
parietal and
science
frontal
revealing
regions.
that
This
ancient
aligns with deep
contemplative
meditative
practices
states.
developed 3,000 years ago in the Himalayan mountains were actually sophisticated neuroscience techniques disguised as spiritual exercises. If you're seeking to understand how the deepest practices of Tibetan Buddhism connect with cutting-edge brain science, and how these discoveries can transform your own mental and physical health, subscribe now and activate notifications. You're about to witness the moment when Eastern wisdom and Western neuroscience finally converged into undeniable truth. Before we continue, we want to be completely transparent with you. This video is produced with the assistance of artificial intelligence for narration and visual generation. However, every piece of research, every scientific study cited, every interpretation and connection made here comes from 100% human curation, investigation, and intellectual work. We believe in combining the efficiency of technology with the irreplaceable depth of human scholarship to bring you the most accurate and meaningful content about Tibetan Buddhism. The journey toward this groundbreaking moment began decades ago, but the acceleration happened in ways no one predicted. For over 40 years, neuroscientist Richard Davidson had been studying the brains of Tibetan Buddhist monks, first meeting with His Holiness the 14th Dalai Lama in 1992. During that pivotal conversation, the Dalai Lama challenged Davidson to shift his research focus from negative emotions like fear and anxiety to positive qualities like compassion, kindness, and equanimity. This single conversation redirected the entire trajectory of contemplative neuroscience. Davidson established the Center for Healthy Minds at the University of Wisconsin-Madison and began the most comprehensive investigation of meditation's effects on the human brain ever undertaken. What emerged from decades of research was so profound that it required entirely new frameworks to understand. The monks weren't just calming their minds. They were fundamentally restructuring their neural architecture in ways that seemed almost impossible, according to conventional neuroscience. The breakthrough studies of 2024 and 2025 built upon this foundation, but took the investigation into entirely new territory. In June 2024, researchers led by Professor Bruno Neri from the University of Pisa traveled to the Serajai Monastery in Bilakupa, India, one of the most prominent centers of Tibetan Buddhist learning. This monastery was originally destroyed 60 years earlier during the Chinese invasion of Tibet and painstakingly rebuilt by monks who escaped to India, representing an extraordinary testament to perseverance and dedication to preserving ancient wisdom. The research team spent 12 weeks collecting electroencephalography data from 23 monks ranging from beginners to advanced practitioners with decades of meditation experience. What they discovered challenged fundamental assumptions about consciousness and brain function. The monks demonstrated an ability to voluntarily induce distinctly different mental states that were immediately recognizable through objective measuring instruments. When practicing concentrative meditation, focusing attention on a single object like the breath or a mantra, the monks showed dramatic increases in alpha and theta brainwave activity, particularly in frontal and posterior brain regions. These changes indicated enhanced attentional control and virtually eliminated mind wandering. But what stunned researchers most was a marked peak in beta frequency range that appeared only in advanced meditators, suggesting that decades of practice created entirely new cognitive capabilities that don't exist in untrained brains. Then came February 2025, and everything shifted again. Researchers at the Econ School of Medicine at Mount Sinai published findings in the Proceedings of the National Academy of Sciences that would have seemed like science fiction just years earlier. Using intracranial electroencephalogram recordings, they placed electrodes deep inside the amygdala and hippocampus of participants while they practiced loving-kindness meditation for the very first time. These weren't experienced monks. These were ordinary people learning meditation in that moment. And yet, even during their first session, measurable changes occurred in the deepest structures of their brains. The amygdala, which processes fear and emotional responses, and the hippocampus, essential for memory formation and emotional regulation, both showed increases in gamma wave oscillations and alterations in beta wave duration. Dr. Ignacio Saez, the senior author, explained that these specific types of brain waves are disrupted in mood disorders like depression and anxiety. The possibility that someone could willfully control these waves through meditation, even as a complete beginner, opened revolutionary implications for treating mental health conditions without pharmaceutical intervention. But the most shocking discovery came in December 2025 from Vanderbilt University Medical Center. Professor Manus Donohue's team used cutting-edge phase contrast MRI technology to observe something previously thought impossible. They watched in real time as expert meditators consciously altered the flow of cerebrospinal fluid through their brains. This clear liquid that bathes the brain and spinal cord serves a critical function. It removes metabolic waste products and toxic proteins that accumulate during waking activity. For decades, neuroscientists believed this cleaning process happened primarily during sleep, when slow rhythmic brain waves synchronize with blood flow to pump waste out through what's called the glymphatic system. Aging and neurodegenerative diseases like Alzheimer's disrupt this waste removal, causing toxic proteins to accumulate and damage brain tissue. The Vanderbilt researchers discovered that during focused attention meditation, the cerebrospinal fluid motion became more efficient, mirroring the exact pattern seen during deep non-rapid eye movement sleep. The absolute flow decreased because regurgitant backward flow was reduced, making the movement more coherent and purposeful. Simultaneously, low-frequency cerebrospinal fluid fluctuations increased and became inversely synchronized with blood flow in brain gray matter, creating the same coupling of biological rhythms that characterizes deep sleep's restorative processes. The monks were inducing a sleep-like cleaning state while completely awake and conscious. This discovery carries staggering implications that extend far beyond meditation halls. Because aging and neurodegeneration consistently show hyperdynamic, turbulent cerebrospinal fluid flow patterns, the meditation-induced shift toward calm, efficient flow suggests a non-pharmacological intervention that could support long-term brain health and potentially slow cognitive decline. The research indicates that mental training through focused attention meditation may offer a method to maintain the brain's waste clearance systems throughout life, protecting against the accumulation of toxic proteins that drive diseases like Alzheimer's and Parkinson's. What Tibetan monks discovered through millennia of introspective practice, Western neuroscience is now confirming with the most advanced imaging technology available. The mind can directly control physiological processes previously thought to be entirely automatic and beyond conscious influence. If these discoveries resonate with you, and you're finding new understanding about the profound capabilities hidden within contemplative practice, take a moment to like this video. Your engagement helps us reach others who are searching for this intersection of ancient wisdom and modern science. But the revelations don't stop there. Another dimension of Tibetan monastic practice has captured scientific attention with equally astounding results. The practice called Tummo Tummo or Tummo translates literally as inner fire. Advanced practitioners claim this breathing and visualization technique generates intense body heat, allowing them to meditate for hours in freezing Himalayan conditions, wearing nothing but thin robes. For centuries, Western observers dismissed these claims as exaggeration or myth. Then in 1981, Dr. Herbert Benson from Harvard Medical School traveled to the Himalayan mountains to investigate. What he measured defied physiological understanding. Monks practicing Tummo meditation raised their peripheral body temperature by 16 to 17 degrees Fahrenheit. They sat in rooms barely above freezing, and researchers watched their skin temperature climb dramatically through nothing but mental focus and controlled breathing. Wet sheets placed on the monks' bodies dried completely from the heat generated by their meditation. More recent studies have revealed the mechanisms underlying this extraordinary ability. The practice involves specific breathing patterns synchronized with visualization of flames rising through energy channels in the body. Researchers discovered that Tummo practitioners can voluntarily activate their sympathetic nervous system while simultaneously maintaining the parasympathetic relaxation response, a combination previously considered physiologically impossible. The meditation allows conscious control over processes regulated by the autonomic nervous system, including metabolism, blood flow distribution, and thermogenesis. Professor Bruno Neri, who studied monks at Sarajay Monastery, identified G Tumo as one of the esoteric meditations that demonstrates a cause and effect relationship opposite to the dominant vision in neuroscience. Rather than consciousness being merely an epiphenomenon generated by brain activity, these practices prove that consciousness itself can manage and control the body's physiological systems. Another advanced practice that has drawn intense scientific scrutiny is Mahamudra meditation, through which practitioners simulate the complete detachment of consciousness from the physical body. Monks engaging in this practice can lower their metabolism so dramatically that they appear clinically dead by conventional medical standards. Their breathing becomes barely perceptible, heart rate drops to minimal levels, and body temperature decreases significantly. Yet they remain conscious throughout, experiencing what Tibetan Buddhism describes as the clear light nature of mind. This brings us to perhaps the most mysterious phenomenon that neuroscience has begun investigating, the state called Tukdam. When highly realized Tibetan Buddhist practitioners pass away, some enter a post-mortem meditative state where the body shows dramatically slowed decomposition, despite being clinically dead. In typical deaths, bodies begin decomposing within hours, especially in warm climates. But monks in Tukdam can remain without decay for days or even weeks. Their bodies retain a fresh appearance, warmth near the heart, and an upright seated posture. Richard Davidson's team has been studying Tukdam since 2007, establishing research equipment in India and Russia to document cases as they occur. The challenge lies in the unpredictability of when a practitioner will pass and enter this state. The research project, chronicled in a documentary by filmmaker Donna Coleman, captures the profound tension between two intellectual traditions investigating the same phenomenon with different methods and underlying assumptions about consciousness, life, and death. From the neuroscientific perspective, Tukdam represents an unprecedented opportunity to study consciousness at the boundary of life. If a clinically dead body shows slowed decomposition and preserved neural activity, this challenges the materialist assumption that consciousness is solely generated by brain function. From the Tibetan Buddhist perspective, Tukdam is evidence that highly trained practitioners can remain in meditation on the clear light nature of mind even after clinical death, demonstrating that consciousness is not identical to or dependent upon physical brain processes. Early findings from the Tukdam project have been published, including the first null finding paper that honestly reported unsuccessful recordings, building credibility for future positive findings. The project has established 3 Russian research centers at major monasteries in Bilakupe, Mungod, and near Dharamsala, training monastic field researchers in neuroscience methods through a program called the Middle Way Approach in Neuroscience. This represents an extraordinary collaboration, where monks become scientific investigators of their own contemplative tradition, bringing both insider knowledge of the practices and rigorous empirical methodology. His Holiness the Dalai Lama has strongly supported this convergence, envisioning a 100-year project to fully integrate academic science into Tibetan monastic education. Through the Emory Tibet Science Initiative, thousands of displaced Tibetan Buddhist monastics living in India now study physics, neuroscience, biology, and philosophy of science, alongside their traditional curriculum, representing the first major change in monastic education in 6 centuries. These developments reflect a profound recognition that emerged over decades of dialogue between contemplative practitioners and neuroscientists. The two traditions are not in competition, but are complementary systems of investigating the nature of mind and reality. Western neuroscience excels at third-person objective analysis, measuring brain activity, mapping neural networks, and identifying physiological mechanisms. Tibetan Buddhism offers 3 millennia of refined first-person introspective analysis, systematically exploring the subjective nature of consciousness through direct experience. The late neuroscientist Francisco Varela, who worked extensively with Buddhist contemplatives, understood that combining these approaches was indispensable for progress in understanding consciousness. His work helped establish neurophenomenology, a research approach that takes first-person experience seriously as scientific data, rather than dismissing it as merely subjective and unreliable. Share this video with someone in your life who needs to understand how ancient spiritual practices are being validated by cutting-edge neuroscience. These discoveries have implications for everyone seeking mental clarity, emotional balance, and cognitive health. The research findings from 2024 and 2025 converge on several revolutionary conclusions. First, meditation is not merely relaxation or stress reduction. It is a sophisticated form of mental training that restructures brain networks, alters physiological processes, and develops cognitive capabilities that don't exist in untrained individuals. Second, these changes are not limited to experienced practitioners. Even first-time meditators show measurable alterations in deep brain structures, suggesting that the benefits are accessible to anyone willing to practice. Third, different styles of meditation produce distinctly different neural effects. Concentrative practices that focus attention on a single object enhance attentional control and reduce mind wandering. Analytical meditation that reflects on concepts and teachings activates different networks. Loving-kindness meditation that cultivates compassion modulates emotional regulation centers in the amygdala and hippocampus. This specificity means meditation can be targeted toward particular cognitive or emotional outcomes, much like physical exercise can target specific muscle groups. Fourth, advanced practitioners demonstrate abilities that expand our understanding of human potential. Conscious control of body temperature, metabolism, immune function, and cerebrospinal fluid flow reveals that the boundary between voluntary and involuntary processes is far more permeable than conventional physiology assumed. Fifth, the mechanisms underlying meditation's effects involve fundamental alterations in brain oscillations, particularly gamma and theta rhythms that coordinate activity across distant brain regions. The unprecedented gamma wave activity that Richard Davidson observed in monks with tens of thousands of practice hours, sustained for minutes rather than fractions of a second, suggests a level of neural synchronization that represents a qualitatively different state of consciousness. Sixth, meditation appears to reverse or prevent age-related decline in brain function. The efficient cerebrospinal fluid dynamics seen in meditators mirror those of younger brains, while the hyperdynamic turbulent flow characteristic of aging is reduced. This offers hope that contemplative practice could be a key component of maintaining cognitive health throughout the lifespan. The philosophical implications are equally profound. If consciousness can willfully modulate processes deep in the limbic system, control autonomic functions, and even persist in some form beyond clinical death, this challenges the reductionist view that mind is nothing but brain activity. It supports what philosophers call neutral monism, or dual aspect theory, where consciousness and matter are two aspects of a deeper underlying reality, rather than consciousness being merely an emergent property of complex neural computation. Tibetan Buddhism has always maintained this view, teaching that mind and matter arise interdependently, but neither is reducible to the other. The clear light nature of mind, experienced directly in advanced meditation and potentially during tukdam, is described as the fundamental ground of awareness that transcends physical embodiment. Neuroscience is now generating data that at minimum leaves room for this view, and at most provides supporting evidence. What practical applications emerge from these discoveries for those of us who aren't planning to meditate in Himalayan caves for decades? The research indicates that even modest amounts of meditation practice produce measurable benefits. The Mount Sinai study showed changes in amygdala and hippocampus activity during participants' very first meditation session. The Vanderbilt research used experienced meditators, but the mechanisms they identified suggest that anyone practicing focused attention meditation would begin shifting their cerebrospinal fluid dynamics toward more efficient patterns. Programs like Yongey Mingyur Rinpoche's Joy of Living curriculum make these practices accessible regardless of religious or cultural background. The 3 levels of awareness, opening the heart and awakening wisdom, provide a structured path that integrates traditional Tibetan methods with scientific understanding of how meditation affects the brain and body. The key insight is that meditation is training, not mere relaxation. Like physical exercise that requires consistency and progressive challenge to build strength and endurance, meditation requires regular practice with increasing duration and depth to restructure neural networks and develop new capabilities. The future of this research field is extraordinarily promising. Advanced neuroimaging techniques continue to improve, offering ever more detailed views of what happens in the brain during various meditative states. The establishment of neuroscience laboratories at major Tibetan monasteries means that highly experienced practitioners can be studied systematically over time, tracking how decades of practice create cumulative changes. The training of monks as scientific researchers ensures that studies will be designed with deep understanding of the practices being investigated, avoiding the superficial or inaccurate characterizations that plagued earlier meditation research. Longitudinal studies following practitioners from beginner through advanced stages will reveal the trajectory of neural changes and identify critical periods or thresholds where qualitative shifts occur. Clinical trials applying specific meditation protocols to particular disorders, from anxiety and depression to neurodegenerative diseases, will determine the therapeutic potential with medical rigor. And philosophical investigations exploring the implications of these findings for theories of consciousness, personal identity, and the mind-body relationship will continue to challenge and refine our conceptual frameworks. The convergence we're witnessing between ancient Tibetan Buddhist contemplative science and modern Western neuroscience represents one of the most significant intellectual developments of our time. For 3,000 years, Tibetan practitioners developed increasingly sophisticated techniques for exploring the nature of mind through direct first-person investigation. They created detailed maps of consciousness, identified specific practices that cultivate particular mental qualities, and achieved demonstrable mastery over physiological processes. Western science, particularly in the last century, developed powerful objective third-person methods for studying the brain and body, creating technologies that can measure activity in individual neurons and map the flow of fluids through living tissue. For most of that time, these two traditions remained completely separate, often viewing each other with suspicion or dismissal. What changed was the vision of individuals like the 14th Dalai Lama and scientists like Francisco Varela and Richard Davidson, who recognized that these approaches were complementary rather than contradictory. The discoveries of 2024 and 2025 represent the fruit of that recognition. They show that what Tibetan monks experience subjectively during meditation corresponds to objectively measurable changes in brain structure, neural activity, and physiological function. The inner fire of Tummo correlates with measurable increases in body temperature and metabolic rate. The sense of expanded awareness in Mahamudra meditation correlates with unique patterns of brainwave synchronization. The deep rest experienced during focused attention meditation correlates with enhanced cerebrospinal fluid cleaning that mirrors sleep. And the profound transformation of consciousness that advanced practitioners describe correlates with neural changes so dramatic they represent qualitatively different states of brain function. This mutual validation strengthens both traditions. Neuroscience gains access to human experiences and capabilities it never would have thought to investigate, without contemplative tradition pointing the way. Tibetan Buddhism gains objective confirmation that its practices produce real, measurable effects rather than being merely psychological or cultural constructs. But perhaps most importantly, these discoveries offer hope and practical tools for everyone. The human brain possesses capacities for self-transformation that we've barely begun to explore. Meditation and contemplative practice provide systematic methods to access those capacities, methods that have been refined over millennia and are now being validated by rigorous science. The toxic proteins accumulating in your brain can be cleared more efficiently through focused attention meditation. The emotional reactivity governed by your amygdala can be modulated through loving kindness practice. The attentional networks that determine your ability to concentrate can be strengthened through concentrative meditation. And the deepest nature of your consciousness, what Tibetan Buddhism calls the clear light mind, remains available for direct recognition through practices like Dzogchen and Mahamudra. None of this requires abandoning your current worldview or adopting any particular religious belief. It simply requires willingness to train your mind with the same dedication you might bring to training your body, and openness to the possibility that consciousness has depths you haven't yet explored. What part of this intersection between Tibetan Buddhist practice and neuroscience resonates most deeply with you? Have you experienced changes in your own awareness or mental state through meditation? Share your thoughts and experiences in the comments. If you haven't subscribed yet, click now to join a community exploring how ancient wisdom and modern science converge to reveal profound truths about human consciousness and potential. Share this video with anyone who might be skeptical that meditation is more than just relaxation, anyone facing cognitive challenges or mental health struggles who could benefit from these scientifically validated practices, and anyone on a spiritual path who wants to understand how their inner experiences connect to measurable brain function. The journey of understanding how Tibetan monks' brains differ from ordinary consciousness has just begun, but the discoveries already available offer transformative possibilities for every human being. Thank you for exploring this remarkable convergence with us. May these insights support your own journey toward greater awareness, compassion, and wisdom.